requirements, technical specifications, like that for the visual aid, like that, how much so on. So, okay, so it's gonna be like the all that equation of my explanation, right? Sorry, it was recorded. It was pre-recorded pala. Okay, now I got to get dental pen now. Yeah, I have something to do, right? I have a lot of things to do. It's not enough. Wow. I don't have time for others. Stop. Yes, I have this. Yes, I have this. Panelines. Oh, talaga. Yes, yes, you. Oh my gosh. Okay, guys, I have to get my pencil pen now. Okay, I have few pencil pens here. Oh, wow! There's a red. There's a red. I did not see this red pen before, just now. Okay. Hello, guys. But I have to take coffee for a while so I can be energized, so that I would not feel asleep. Okay. For a while. Oh my gosh, what's happening? Really? Excuse me for a while, before we go to our discussion proper, okay, about Raolts Law. Oh my gosh. Okay. Guys, this topic really is, very common in our profession, chemical engineering, and this has been so many times came out in the board examination. Okay. Like this. Okay, guys. Oh my gosh. Hello guys, here is my coffee. Wow. Here is my coffee. Oh. And this is specifically Ali coffee. Okay. Ganon. Okay, Raolts Law is a very important topic of physical chemistry, though it has been discussed in general chemistry lecture already, but that was a basic foundation only. In here, we have additional some, techniques how to solve, shall I say, average, above average, little difficult, and difficult problem solving. But we'll never go to the difficult problem solving, only in the average, above average, and a little bit difficult. A little bit difficult meaning we can manage. Okay, but for the difficult, we don't try to, we don't have to put problems on our head. Okay, because I tell you honestly, in future examination, board examination, that's not difficult too much. Okay, it's only our mentality and psychology that tells our brain cells, oh, it's difficult, but it's not. Okay, that's the technique already. Positivism. Mogi na siya number 1, positivism. Okay, in taking examinations. Okay. But of course, there are also topics that you'll never encounter before, especially before going in my high school days. Because I love science really. When I was in high school, elementary, something like that. Okay, I represented our school together with other classmates. Oh my gosh, very difficult really. Okay, the kind of examination is written examination, not really the formal quiz bowl that you are in the group of tables, and then the question there's somebody will ask questions and then you raise your answers like that. It's not like that. It's one, oh my god, there's a lot of topics that I don't know, really. I tell you honestly. But I remember one question there about experimentation. Okay, there's a situational equation problem there, and what does this guy do in order to prove? And the answer there is he has to repeat his experiment because science is always repetitive. Okay, if you cannot get that in one time, you do another experiment or proven to be tested. That's all about science or scientific research. It's a lot of experimentation. That's why we have trial and errors. Okay, something like that. Okay, so I remember that question. That's only one I can remember. Okay, and there's other thing also regarding the silicone. Actually, guys, when I took up board examination, really, okay, I remember that silicone answer, right? The main abundant component of a soil or a sand. That's the question in board examination. I remember pala, it was taken pala when I take the science quiz ball in University of San Carlos. There's a question like that, okay? And then I apply that also in the board examination. Meaning to say, stock knowledge. Okay, it is not in the review, but stock knowledge, yung things like that. Okay, because I researched that silicate is always silica. Okay, SiO2. Then the question is, element man siya. Silica is a compound, it's not an element. The question, what is the most abundant element in soil? So I could not answer silica because silica is a compound composed of silicon and oxygen. So through experience in joining competitions like that, so it will be really helpful also. Okay? So that's gonna be, I will take my coffee first. Oh my gosh. Shout out pala sa ako mga classmates sa National High School. Sa ako mga classmates sa elementary. Okay. Ganun. Grabe mo to sa una kay we have a close competition academically and then it maapsan gani, maningkamot na yun. So, but I don't know nowadays in 2012 to 2021 if students are like that. But in our time, really, it's a healthy competition. We need to study a lot because somebody will be at your back, point something. Hindi ka magpapiling, ana ba? So, I don't know nowadays if yung anak mga estudyante. But before, in top 5, something like that, okay, so study, and then something you will gain a lot of harvest after all. Okay, to become a consistent honor student. Okay, no, not really that rich. Your family really, for example, your father is only a farmer, not farmer, driver, something like that, and then no enough money, then you can help your parents also through your scholarship. Okay, especially if you are so inborn. Sometimes you will never force that to happen to you. When you grow, it's already in you. All you have to do is to okay, plus the acquired knowledge and bingo. Okay, so ourselves to force ourselves to scholar because it's up to individual capability talaga siya. Okay, average like this. So it depends what God given to us naturally at the time we are born in this world. Okay? Because sometimes we cannot also force to be intelligent or whatever. Okay? Maura jud diha jud takutob sometimes. Okay, we cannot reach more than that because that's our limit. Mental ability limit. Even though how hard we try, even though how we try in going to the library to do research, reading a lot, something like that. Okay? Even though a billion of times you will go to the library, but your mental ability limit is just like that. So you'll never go beyond that. Okay? Something like that. Just like Hooke's law, elasticity limit. You remember that one in physics? Hooke's law, Hooks law. When the limit to reach, the rubber band will break. Okay? Because there's a limit in everything. Because materials has limits, the same person also has a limit. Something like that. Okay, now go back to the illustration. So good data. Okay, Raolts law. So this is his law, that's why it became Raolts law. Okay, like that. Okay, S V S L E W. So Raolts law. Okay, according to Raolts law, okay, it states that the vapor pressure of the solution, or shall we say, the vapor pressure of the liquid above solution is just the same because in equilibrium, right, is equal to the mole fraction of the solvent, okay, or the fraction of the solvent, okay, or the liquid, because normally solvent is a liquid, right? Okay, since our example always water most of the times because water is the most common or aqueous solution, that's why we use water. But there are also instances in other problem solving that it could not be water anymore. For example, ethanol, methanol, alcohols, okay, chloroform, any bin mixture, something like that, because it's not limited only to liquid mixture, solid liquid mixture, gas to liquid mixture. It's gonna be like that always. Okay, so you have to limit, not to limit, you have to maximize your, understanding regarding the three states of matter: liquid, solid, and gas. Okay, ang sa ganito, matter is anything that has mass and occupies space. Okay, mass meaning in the planet Earth. Okay, something like that. Because there's also weight. Actually, it could be the same also. Other books stating that one as anything that has weight and occupies space. But it's also okay to say that has mass. But what if those materials are directed downward towards the ground? So it's no longer weight because weight considering the gravity. It should be better to say that anything that occupies space and has mass, not weight. You get the point? Okay, remember your weight and mass when you go to the moon is not the same. Okay, so just like that also we try to use the mass lang siya to make it safe para walang gravity. Okay? Generally, okay. Okay, now I will try to put that here. Oh my gosh. Like that. Okay, so the vapor pressure of the solution, shall we say that the VP, the pressure, right? So the solution will be cut to SOL, and for easy identification, because writing too much word also takes time, right? SOL apostrophe kakaloka. Okay? Like that. Mole fraction represented as X. Usually in science, mole fraction is always X. Okay? But guys, mole fraction, it depends on the situation, huh? We can also use volume. We can also use mass. We can also use pressure, but still fraction X to be used. Okay? Because volume fraction, mass fraction, okay, like that. It's not only limited to mole fraction, it's specific entropy in the physical chemistry. As remember, the saturated steam vapor, like that, and the superheated vapor. Okay, we use their mass fraction, remember. Mass fraction, meaning the dryness factor or the fraction. Mass of the liquid over mass of the liquid plus mass of the vapor. It's just the same here, fraction. But the only difference is that this is mole, M-O-L-E. Okay? The basic amount unit of a substance is called a mole in chemistry. Okay? So X of the water times the vapor pressure of water. Oh my gosh. So you remember in my discussion last 2 days ago, or I couldn't remember, right? So it's gonna be 3 days ago. It is at 25 degrees Celsius. We have, for the pure water, we have vapor pressure of 23.8 torr. Okay, you memorize that, right? Same as the way I memorize, right? So it's always like that. At standard temperature, 25 degrees Celsius or 298 Kelvin, the vapor pressure of pure water at 25 degrees Celsius is 23.8 torr. Kana lang siya, i-memorize na siya kay wala na dyan problema sa ubang unit sa pressure. It can be converted to PSI, G, to atmosphere, to bar, then bingo. Even though you have only one memorized value of the standard pressure at standard temperature. Okay? Don't be confused also, guys, because other problems also in science, they will use only room temperature. They will never mention anymore 25 degrees Celsius. Really. But actually, if you try to dig it out based on my research, that's gonna be 20 to 25 degrees Celsius is the range of room temperature. Okay? Just like in your AC, that's gonna be the range always, right? Observe that when you are in the office. You will never go beyond 25. You will never also get less than 20 because that's too cold. 19 and 18 degrees Celsius. That's why they call that, according from our scientists, room temperature. Okay. Now, unless specified, guys, we are very lucky in the problem solving. Sometimes they will really mention 20 degrees Celsius, right? But if it does not mention the Celsius, the specific temperature, that's automatic 25 degrees Celsius, guys. For example, if I have benzene at room temperature will react to ethanol, right? You don't get the specific temperature. Use 25 degrees Celsius in your value, so because this is not water anymore. That. Why? Because you are using the same reference temperature. Okay, so at 25 degrees Celsius, vapor pressure of benzene, X. Let X, the vapor pressure is 23.8. So ratio and proportion right away. Get the point? Because it has the same temperature. Okay, and they are the same liquid. But never do that if the phase is not liquid and the other is solid. Get a point? Okay, be careful because we have the Paris Chemical Engineering book. We have also General Chemistry book, the orange, the Fred Moore, the physics, and a lot of physical properties of pure substances. Okay, table, right? So that's why I advise you to memorize only the most common. You can also memorize the most common. That's why. Okay, not memorize everything about it. So many really guys, or ethanol, the gasoline, something. Because that's common. May mabalik-balik naman siya sa problem. Water, oil, ethanol, methanol, like that, or even benzene, memorize also at 25 degrees Celsius vapor pressure. So that at least you could no longer scan the handbook or the chemistry book in get to the handbook board examination in October, memorize the most common pure substances, constants, and values. Guys, okay, not depend on the handbook. Okay, like because that's very common. Okay, vapor pressure of water, the vapor pressure of benzene, the pressure of, it's up to you. Okay, at 25 degrees Celsius, so that you can save your time in scanning the Paris Chemical Engineer's Handbook, but you know already that 25 degrees Celsius. Okay? So it can save you time, really, it will help a lot, really. Siya all over the world, water. Okay? Like, it's the vapor pressure of water. My gosh. But in real slow, guys, it does not focus only in 25 degrees Celsius, ha? I'm just telling that as an example. Because there's a lot from 0 degrees Celsius to 100, like that. It depends on the situation, what the problem is all about. Now, so X is a mole fraction. Now we need to illustrate. Okay, our y-axis will be the vapor pressure of the solution here. Okay, like this. Okay, by the way, guys, what is, we need to use terms so that we can understand really the topic. There's also insoluble and soluble. Okay, try to dismissible and miscible. Okay, number 3, compressible and incompressible. Technical terms, Newtonian and non-Newtonian fluid or liquid. Okay, like that. And lastly pala, hydrophilic and hydrophilic kung saan na siya. Okay, so that you will understand really how it will interact as you mix this 2 or 3 components. So because not all the time they are soluble with each other. Okay, they will not be separated. Okay, and others also will be separated. Others also will go up and others go down, just like water and oil. Okay, something like that. So in that manner, you should detect the density. Okay, regarding about floats up and sink down, so it matters on the density already. Okay, something like that. You have to smart enough to distinguish again insoluble or soluble, immiscible or miscible, incompressible or compressible, hydrophobic or hydrophilic, something like that. And also polar and non-polar. Okay, so that you can understand really what is science all about. Okay, because if you are lack of, knowledge, stock knowledge really, even though how you are good in problem solving, sometimes there's furious questions manggod siya. So it could not be denied. It can add points when you take the examination. It's not all the time always problem solving. I tell you honestly and frankly. Okay, before. Okay, so you should be, as I told you all the time, be a wide reader. Okay, read before taking the examination. And at the same time, you also memorize yung mga words that you are not unfamiliar with. Okay, like this, or any processes, whatever, chupa chupa. Okay, ganon. Okay, going back. Sa siya. So y-axis is the vapor pressure of the solution. Okay, like this. Okay, vapor pressure of the solution. Okay, like this. Okay, by the way, what is the difference between a solution and a mixture? You have also to know that, the definition. Okay, it looks like the same, but there's a slight difference. Okay, mixture and a solution. Define, differentiate between a solution and a mixture. Okay, research that for yourself also. Okay, it's not good also to spoon feed every time. Okay, like so, this is mole fraction. Okay, mole fraction is represented as x. Okay, ganun-ganun siya, chupa-chucho. Okay, like that, and we have here 1. Oh my gosh. This one. Okay? So guys, in this manner, if the equation and formulas involve, involve mole fraction like the blah, chupa-chucho, usually if pure talaga siya, it will never mention as 1. It will be just mentioned quality is 100%. But automatically that is 1, your mole fraction. No need to compute because it's already pure and the quality of your, for example, your solute will be 100%, then that's automatically 1. Don't use the 100% because you cannot multiply that in a certain figure. That's percentage. Okay, automatically use 1. 1 is equals to 100% na talaga siya. In chemistry, we talk about quality or concentration or whatever, chupa-chucho. Okay? Okay, gets? Because some problems don't have to specify, for example, 0.23%. So you no need, sometimes you will mention pure sodium chloride or ganon. So pure, so we have to say 100%. 1, mole fraction tayo, automatic. Ay napaglugay-lugay, pure man siya. So take note also the how it is being phrased in the problem. The word pure is already a detection that it's purely concentrated. Okay, 100%. So 1 na yun sa mole fraction. Mga techniques it's like that you have also to discover. Okay, because that is basic. Okay, like that. If not mention the word pure, then you have to compute. Okay, because not all the times also it will be mentioned as pure. But sometimes it will be mentioned and you make your head too much thinking, oh, how can I do this? There's no given for the moles. This is pure. Why you should get the moles? It's already pure. No need to get the molecular weight. You need to get the, something like that, guys. Okay, it's really needed. Okay, especially for an engineering student. Okay, because usually mathematics will be there. Okay, so x 1. Then siya. Okay, this is small fraction of solvent. So this is water. Okay, guys, don't be confused. Don't be confused because in Raolts Law, guys, this is water. It's not solute. Okay, but some students, including me, I will be confused sometimes when I was in college 20 years ago. Sometimes I will interchange, but this is really solvent, the mole fraction here, not the solute. Okay, like that. Because some instructors also will not specify. Automatic na lang siya. Butang na niya ang solute ito. Understood that the students know it, that this is really always solvent, but you have to discuss that this is really liquid in your discussion because not all the students can understand really because there are two. There are solute and solvent. You have to specify that the students really engraved that in their brain cells or not the solute so that they will not be confused. I hope and I pray instructors are like that. You need to introduce to them the specific really, not only something like this and you just follow the pattern. No, it's not like that, okay? Because they will not understand. Okay? Even though I am not an instructor, but I tell you honestly because I also read books of methods of teaching, something like that, okay? Principles and methods of teaching. Okay, though I am not a certified and legit instructor in a university, but I read a lot of sources how to discuss like this, blah, 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 so and so. Okay? It doesn't mean also that if you are only an instructor, you can do the discussion. Anybody can do the discussion as long as you have wide information, you research for that, something like that. Okay? So it does not limit to, instructors that taking up education. Okay, anybody can teach. Okay, even though you have a formal way of teaching, that's only the difference. So they are the most, preferred, not us. But what I mean, such like this informal way of education or sharing information, it could be okay. Okay, like that. It depends on the situation. Most of it depends on the mental ability of the individual. Because not everybody can talk well, communicate well in, in virtual platform, and not everybody also can talk very well in the public, okay, or in people, in front of many people. So it's a gift that God gave to us. Okay, just utilize what God gave to you. Okay, because we cannot force on the other areas because it's different specialization in different individual. Different human being has different gift, okay, or talent, something like that. And we should utilize, right? Something like that. Ganon. Hindi yung magsisiraan. Okay, now, we have now the x here is very clear, right? Okay, so this is small fraction nasa x-axis. Okay, let's say I have to put x water. So normally, guys, in physical chemistry, only two siya. Seldom, only 3, 4 mixtures. But usually, most of the time, 2 components lang good siya. So we can let A and B. So in this case, I will let A for water. So this is gonna be XA. Okay? XA, ganun siya. Okay? Usually, A and B lang good talaga siya. It depends man siya good. Pero but in this purpose, we need A as water. 2 lang. 2 components. The water, let us say the water and the strong electrolyte, sodium chloride. Okay? Strong electrolyte. Okay? So is electrolyte, right? Okay? Has a high degree of ionization. Okay, ganun siya. So, XA. So, if I will say XA is equal to 1, what will be your XB? Your XB will be automatic equal to 0. Okay? Because your XA is 1. Right? And then if the reverse is I let XB equal to 1, then your XA also will be equal to 0. It's just like that. Okay? Okay? Meaning to say, the total is 1. So, mole fraction A plus mole fraction B is equal to 1. It will never go beyond 1. Okay, got the point? Okay, it's less than always 1. Okay, XB is equal to 0. Now, if you try to plot this in this manner, okay, after the data test results in the laboratory, you can obtain a straight line pointing upward, something like this. We don't have to plot one by one because this is not an experimentation. This is only overview discussion. But if you try to, it will also be like this based on the scientific research and proven research studies of Mr. Raolts. Okay, because this is Raolts Law. It's gonna be like that. So this is our vapor pressure of component A, which is water. Guys, I told you, if there is a circle at the top, that is vapor pressure. And that is also what we called as standard value. Remember the standard value of enthalpy, standard gives free energy. There's a small 0 at the top of the triangle, right? Delta is a triangle, right? So delta G, or triangle, circle at the top. Okay, delta S, entropy, small circle at the top. Actually, guys, that is also standard. But in here, we treat the small circle at the top of the letter as vapor pressure when we deal with specifically with pressure siya. Let's agree before going further discussion because we put 0 at the top man siya of the letter P. Okay, this is vapor pressure. But remember, I need to emphasize this because we have also partial pressure. Okay, but this is not partial pressure, this is vapor pressure. So that to distinguish among the two. This is very important so that we will not be confused. Okay, something like that. So this is vapor pressure of water or A component. So I need to put capital P, small circle at the top, then subscript A. So this is vapor pressure A or vapor pressure of the water. Okay, like that. You get the point? Something like that. So now, what about the B component for the sodium chloride? Assuming lang good siya, guys, not really that specific because we are not inside the laboratory to do a lot of testing or trials. Okay, so in our salt, we said that Xg is equals to 0. So they are reverse, opposite with each other because the mole fraction is 0. It's in here man siya. So automatically, the intercept will be here. So it's opposite with each other. Okay. But if you try really to plot that one, it's gonna be like this also, ha? Okay, this is only for the purpose of discussion, an overview. Okay, something like that. Okay, now we have to do this. Okay, like an X. So this is our vapor pressure of sodium chloride, small circle at the top of P, then subscript B, which is NaCl. Okay, like that. So P, vapor pressure of B and the vapor pressure of A, like that. Okay, now, NaCl is a non-volatile solute. In the theory and concepts of general chemistry lecture under colligative properties, if you add non-volatile solute, what will happen to your solution? So theory. In chemistry theory, if you add a non-volatile solute, your vapor pressure of the solution will always decrease. Okay, put that also in your brain cells. Okay, again, if you add a non-volatile solute, so then how can we identify that it is a non-volatile? If that is a salt or electrolytes. Okay, that's our identification that is a non-volatile. For example, positive charge and negative. So those are non-volatile, meaning those compounds that undergo ionization chemical reaction through its charges. Something like that. Remember, the sodium positive will dissociate from chloride negative if you put that in aqueous solution or water. That means that this compound is an electrolyte, or we have an electrolytic solution. So this is specifically an example of a non-volatile solute. But this is limited to sodium chloride also because there's a lot. For example, sodium sulfate, zinc sulfate. As long as there is a negative charge and positive charge compacted with each other or partnered or combined with each other, a compound. So that is a non-volatile solute, or usually a salt. Because technically, a salt is an electrolyte by definition. Okay? So ay naglubugan yung utok, a salt. Because if you add also sugar in water, that's another thing. Because sugar is not it will not undergo ionization chemical reaction. It is not under ionization process. That is not a non-volatile solute. Okay, remember that one. Okay, the formula of sugar in our kitchen, there's no negative charge for that. Remember, carbon 12, H22O11. Okay, something like that. But the oxygen is completely used up in the other partner of carbon and hydrogen in a non-polar covalent bonding. Okay. So, see, in Raolts Law, we should also remember the bandings, the type of bandings. What are those bandings in general chemistry lecture? Okay, we have, based on our stock knowledge, we have covalent banding, right? It could either be a polar covalent banding or non-polar covalent banding. Then we have the hydrogen banding. Hydrogen banding, example, the water. It has a dipole-dipole banding. Okay, specific orientation of the hydrogen. Okay, we have the ionic banding. This salt, this is ionic banding. This is non-volatile, so ion to ion banding. We have also the van der Waals banding. The van der Waals banding is weak. Okay, weak to react with other. For example, the inert gases in the last column in the periodic table, such as helium, xenon, neon, krypton, argon. Oh, those are inert gases or noble gases. Okay, that will undergo van der Waals banding. Okay, what else? Ion to dipole banding. Oh, so you have to familiarize that definition and understand it because we will be using that here. Okay, something like that. Okay, in here, sodium chloride is ion to ion banding or ionization chemical reaction, so non-volatile solute or electrolyte or salt. Okay, remember that one. So our vapor solution will always decrease. Okay, now, if your vapor pressure is 23.8 originally, if you decrease also your vapor pressure of water, automatically your vapor pressure solution will decrease also. Why? Because this reaction guys, vapor pressure of solution equals the mole fraction of water times the vapor pressure of water. If you take this mathematically, solve the vapor pressure of water, it will give us vapor pressure of the solution over the mole fraction of water. So in mathematics, that is directly proportional with each other if they are facing at the top in the numerator. So they have dependency with each other or dependent with each other, specifically directly proportional with each other. If we increase the vapor pressure of water, your vapor pressure of solution also will increase. If you decrease your vapor pressure of water, your vapor pressure of solution will also decrease. So meaning they are going with each other. Okay, aside from adding a solute, that the vapor pressure solution will decrease. Okay, so if you can see, guys, this Raolts law is specific in the colligative property example of vapor pressure lowering. Okay, because there's a lot in colligative properties like vapor pressure lowering, boiling point elevation, okay, freezing point, okay, depression or reduction, and the osmotic and osmosis pressure, right? The four. So, and remember, that's the time we need the Van Hoff constant also. Like, what's the Van Hoff constant? So, we don't have to deal with that. Okay, there to review, we can record. Our topic is another here. Okay, what I mean is we have to remember. Okay, so it's gonna be like this. Oh, ganon. So, we will connect these two before pressures of A and B. Put an imaginary line. O, ganon. It's gonna be like this. Ganon. So, straight line. Okay. Now, straight line. You connect the vapor pressure of A and vapor pressure of B. So, what is this if you connect the two? I will question you. It is the sum of the two vapor pressures or it is the sum of the two partial pressures? Okay. This is total pressure is equal to the partial pressures. Okay, it's sum of the partial pressures A and B. It's not the vapor pressure because there's also another quantity, this mole fraction. You have to gather all the quantities, not only for the vapor pressure. It's become PT total or total pressure is equal to partial pressure of A. Now we do not denote a small underline above the P to denote that this is a partial pressure. Okay, partial pressure of A, underline above the P, plus P, B. O ganon, this is total pressure. So partial pressure of A plus partial pressure of B, or partial pressure of water plus partial pressure of sodium chloride. Now, this partial pressure sodium chloride has also its own formula, basing on the Dalton's law of partial pressure. So, it's connected with each other. In here, the Dalton's law of partial pressure. So, ganito, Dalton's law, that the sum of all partial pressure is equal to the total pressure in a system. Okay? It's gonna be like that. So, partial pressure of A now, according to the Dalton's law, will be equal to, okay, partial pressure of A is equal to the mole fraction of A, now, times the vapor pressure of A, in which we connect that in our graph. Okay, partial pressure of A is the mole fraction of A times the vapor pressure of A. So you need to be clever enough that there's a lot of terms for pressure: vapor pressure, partial pressure, total pressure, absolute pressure, vacuum pressure, gauge pressure, absolute pressure, atmospheric pressure. You have to identify each word by word, understand it by your brain cells. This have definition technically so that you will not be confused if it will be put in a problem solving. You will not use all the time because, for example, that is not an atmospheric pressure. Then you don't use that right away. For example, the problem is giving only the gauge pressure. You will not substitute that in the equation of Raolts law because we have the absolute pressure is equal to the atmospheric push pressure plus the gauge pressure. Like that. So be careful also. We have absolute pressure to be used, not the atmospheric and the gauge. Okay? But usually, if not specified, that's automatically the atmospheric pressure, something like that, normally. But you can sense also to the problem, right? But what I'm telling you, to be careful with the terminologies. Okay? Because sometimes you cannot also use directly the pressure. that is mentioned in the problem. Okay, because there's a lot of types of pressures, as I mentioned a while ago. Okay, in here we are involving only partial pressure and vapor pressure. Okay, like that. So this is the partial pressure of A or water. And now for the partial pressure of water B is equal to the mole fraction of B times the vapor pressure of B. Oh, ganon. Ganon siya. This is only good class if there are two mixtures, ha? Okay, this is liquid to solid mixture. Sodium chloride is our solute or solute, and our solvent or our liquid is water, specifically in this particular illustration in the graphs. Okay, something like that. Now we need to solve for the mole fraction of A or mole fraction of water. How can we do that? Okay, but again, by having the knowledge of general chemistry lecture in the topic, particularly in the measures of the concentration expression. Remember? So we have the molality, normality, molality, like that, equivalent of solute, something like that. This will be applied here. The percentage by volume, the percentage by mass, okay, it will be applied here. So XA is equal to mole fraction of A. Ganun siya. Okay, this is very basic, guys. It will, even though in the higher science question, it will be keeping on repeating like that examination. But I cannot state to you what that really, because it was 20 years ago. Okay, I cannot remember specifically, but there is. Okay, really. Okay, so XA is equal to, I can remember most of the time the theory questions, but for problem solving, I cannot remember already because it's a paragraph form. Okay, paragraph form meaning too lengthy. We cannot memorize what really is that all about. Could it be in distillation, humidification, leaching, heat transfer, momentum transfer, distillation, heat transfer dealing with heat exchangers. So we can attack, but for the theories it's very easy to recall. Okay, for example, what is the lightest particle in the nucleus? Oh, it's very easy. The answer will be electron, something like that, because it has a mass of 9.11 times 10 to the negative 31 kilogram, lighter than protons and neutrons. That's gonna be like that. Okay, so mole fraction, so XA is equal to the mole fraction of A, okay, over Na plus NB. Ganon. Okay. Guys, consistent jud siya. N is the symbol for number of moles as we go along the way, especially also in the chemical calculation or CHE calculations or the stoichiometry. Okay, small letter n is really the symbol of the number of moles. Okay, now if we have XA, then substitute that here, then bingo, you can have XA. Now, I will also solve the XB because you cannot get the X of A if there's no XB, the mole fraction of sodium chloride. So it will be equal to NB is equals to NB plus NA. Okay, guys? Like this. Okay, now Na plus Nb is equal to 1. Okay, or Na plus Nb is equals to 100% quality. That's also 1. Sometimes also not given the value of number, but sometimes telling also like that. The quality of sodium chloride is 100%, like this. Okay, so we need to think also like that. Okay, bingo na siya. The only different now is how we do the attack in the problem solving. How we try to analyze the problem is the only phrased in the problem. It's not all the time the same as the example of our instructors did. Sometimes it will be, rambled, and sometimes you cannot imagine because, for example, our topic is real flow. Then the question will say, what is the diameter of the pipeline? Right? It's very far. But our topic is dealing with pressure, but the question will say like that, what is the velocity of the, for example, sodium chloride that will go to the tank? Okay, combination na siya. So apply the steady state flow, always all the time. Okay, chemical equilibrium. 0.21 is equals to 0.2. 0.2 is equals to 0.3 because that is for simplification. You can simplify that. If you simplify that, then a lot will be cancelled out. So you can solve what is being required. Something like this. Remember only that one, and then it's okay because this is an equilibrium steady state law, especially the Bernoulli equation. Okay, memorize that one because it's about masses and energies. Okay, and pressure, but most of the time it's gonna be like that. Because, for example, this is a real law, and then in the actual examination, they will be mixing that, and if you try to think, it's gonna be like, try to go to the basic language na, try to apply, okay, the basic para di lubog ba? Because the purpose of that is to lubog Jude. Okay, so that you will be confused and you can no longer get the correct answer because they want to regulate. Okay, they want to regulate how many passers will pass in that particular examination. Okay, that's why they put some difficult questions and some difficult problem solving because we want to regulate how many engineers will pass on that particular year. Because year that the PRC job, something like that. Okay, now going back to this real zone. Okay, it's gonna be like this, class. No need to intensify further, right? Okay. Any questions so far? So this real low, nothing. Okay, by the way guys, this is not like expect that if you add a volatile solute, then your vapor pressure solution will also decrease. It depends na talaga siya. After your solution, you can compare like that, okay? Because the basic lang, what trying to say in the basic is non-volatile solute magud siya. It never tells the volatile solute. But if in the future, if the volatile solute will be added, then through your answer, you can say that the vapor pressure will decrease, will increase, then memorize na talaga siya na it's gonna be like that. But for me, I did not encounter yet for now. Okay, maybe tomorrow or in the coming days, I can encounter two liquid. If you add volatile solute, the vapor pressure solution will increase. But for now, not yet pa siya. Limited for non-volatile. The point? Though we can make it not also through theories and principles, but it take a longer time to analyze. Okay, because you have to think the theory 1, theory 2, theory 3, theory 4, theory 5, and you can come up really, upon the addition of volatile solute, the vapor pressure solution will also decrease. Even though you did not meet any problems regarding that, you can still have that. But a lot of thinking will be managed. You have to think up before arriving at conclusion. Okay, you will gather all the theories, the equations, and then at last you can say, if you add a volatile solute, the vapor pressure solution will also increase. But for now, not yet because I don't do that. Okay. The basic theory states only that if you add a non-volatile solute, the vapor pressure of the solution will decrease. Like that. Okay, something like that. And I did not also memorize that. Okay, something like that. Okay, thank you so much for watching this live streaming. White live streaming. If you like the content of this information, then you can comment down below in the comment section, and then you can subscribe my YT channel if you want, and you can also click the notification bell for some news updates. I am a singer, eternal voice. Bye bye guys everybody. See you later for another segment of YT live streaming. This is again, I am a singer, eternal voice, occupational safety health engineer, and a chemical engineer. Thank you so much. Bye bye. God bless everybody.